I'm Mark Sponsler, and welcome to the Stormsurf video surf forecast for the week starting Sunday, December 15th. Tonight we'll be discussing jet stream level winds, sea surface pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean, and of course, a look at snow for the Sierra and Pacific Northwest. Let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see an area of 26, 27-foot seas over broad area, almost filling the entire Gulf of Alaska, all aimed to the east, but also sending sideband energy towards Hawaii. This from a system that traversed the North Pacific Ocean, and yet another system is developing off of northern Japan and expected to do a very similar track and cause the same level of damage or swell production. We are in a pretty good pattern right now. Let's start digging into the details. As usual, we like to start looking at the jet stream. These are winds up about 30,000 feet that help support the formation of gales. That is when the jet stream forms into a trough, a dip going to the south, sort of like that right there. That helps create a counterclockwise flow aloft in the atmosphere and at the ocean surface, and counterclockwise flow in the northern hemisphere is the sign of low pressure. Low pressure, if it's strong enough, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So we have a pretty good pattern here. The jet stream is, for the most part, consolidated. A little bit of a split here over Japan. Once it gets out over the Northwest Pacific, consolidated, building to, about 160 knots, forming a little tiny trough right there. And we know from looking at the wave height charts just a second ago, there is some low pressure forming there that is already generating seas. There's also another trough here in we call it the northwestern Gulf of Alaska, that is fading. It's a weaker trough. Notice there's not that much wind feeding into it, so it's doing less for swell production. And then remnants of the jet still consolidated, pushing into Northern California as of 4 a.m. Sunday morning. Okay, we'll make it about, there we are, right now. Still pushing over the San Francisco Bay Area. All right, putting this into motion, looking out, the trough off Japan gets a little bit better organized. The trough in the Gulf starts getting pinched off. That provides less support for gale development. We'll just roll this out. But you notice it's moving closer to the U.S. West Coast. If the trough can hold together, that might make some weather, some more rain, and maybe some snow. All right, trough in the west, not looking so good as of Monday night. Into Tuesday, not even good. The jet actually starts splitting a little bit. And here comes the trough into Tuesday night, into Wednesday, getting ready to push into, we'll say, northern and central California. Here's the split in the jet. Still some sort of low pressure. It looks like a troughiness in the northern Gulf there. Continuing into Thursday, the jet re-energizing over Japan at 170 knots. That's a good sign if we can get a trough out of it. Look at this trough in the Gulf continues into Thursday and Friday. Looks like yet more weather for California. A little bit of a ridge here, though. High pressure when the jet is ridging, low pressure when it's troughing. We're into Saturday. We're almost a week out. Here we go. Nice trough developing, being fed by 180 knot winds. Going into Saturday night, and then into Sunday, where are we? We're at 180 hours. So another trough. Big trough off the California coast. Not so much interested in swell production here, but probably weather production right before the Christmas holidays. Interesting. Hope you're not traveling right then. At least in this area, that could be a bit problematic. All right, but in general, jet stream consolidated for the entire week. Multiple troughs queued up, all pushing off to the east. Wind levels not really high, but not horrible. Not a bad pattern at all. Let's go take a look down at the surface and see if the jet stream pattern manifests itself lower in the atmosphere. So here we are, surface level pressure, surface level winds. High pressure right off of California at the moment, making for north winds and kind of a messy ocean state right now. Swell in the water, but not really touchable, given all the wind and wind chop. Whoa, there we go. All right. At the same time, low pressure in the Gulf of Alaska, generating 30, 35 knot winds, still generating some seas. We know that. It's 26, 27-foot seas up there. New gale developing off of the southern Kuril Islands, North Japan, 45-knot winds. We'll keep our eye on this one. I think this is going to be the main swell producer as we get into Monday. 45-knot winds aimed right at Hawaii. Certainly looks like a swell producer. Low pressure trying to organize a little bit in the Gulf as we get into later Monday. There we go. Now, 35-knot winds in this one, all aimed off to the north. It's more looking like precipitation potential. Get into Tuesday. Here we go. That low that was previously off Japan, now in the northwestern Gulf of Alaska, still producing 40 to 45-knot winds. Looks like a swell producer. And a front queuing up off the California coast into Tuesday, kind of washes out as we get into Wednesday. Weak low pressure limping into the central California coast Wednesday morning. Low pressure in the Gulf of Alaska. Big fetch of 35-knot winds. That certainly will produce swell. We just need some conditions to go along with it. Maybe Northern California is the place to be. The system continues into Friday. Is it going to sink south? We think it will. And then watch over in here at some point. Here we go. New system developing over the North Dateline region a week out on Saturday. 40-45-knot winds. Weak low pressure off the California coast on the 21st. And the 20th. Look at, oh, wow. Quite nice. 55-knot winds forecast on Sunday, the 22nd, over the dateline. Certainly that'll produce swell. Kind of a windy, blowy pattern over the Hawaiian Islands. Things looking to lighten up a bit off California as we get into Sunday. And there we are, Sunday night. Weak low pressure over California. Gale low with a solid fetch of 45-knot winds, if you believe the models a week out, aimed at the U.S. West Coast. And another gale developing behind that. So, pattern looking good. What's the effect of these winds on the ocean surface? So we're going to go back in time just a little bit. 2 days ago, Friday morning. There was this low that developed off the Kuril Islands. It built there for a little bit to, what was that, 30, says 40-foot seas, but really, oh yeah, tiny area. We'll call it 39-foot seas reasonably. And it kind of weakened as it pushed over the date line into Saturday. Still 28, 29-foot seas. That's good for 15, 16-second period swell, radiating towards Hawaii and the U.S. West Coast. We're into Sunday morning. Here's where we are right now. Let's go to the forecast and see where we go from there. Yes, the gale in the Gulf redevelops this evening a little bit. Small area, 30-foot seas. The next gale, weakening, 32-foot seas, getting ready to push to the date line with, 32-foot seas on Monday night. Still, I mean, you got basically a swell-producing machine going on here. Seas up to 35 feet as we get into Tuesday morning, building to 30, we'll say 38 foot midday Tuesday, continuing through the northern Gulf. Notice this little area of 20-foot seas right off of Central California. In fact, let's go back. Yeah, so the models have been kind of all over the place on exactly where it's going to form, how strong it's going to be, but the net result is some raw, stormy swell, probably isolated for Central California down into maybe Southern California when it arrives. And then behind that, much seas or swell from the gale in the Gulf, still producing 30-foot seas, then fading out. Thursday, things kind of back off. Yes, we have a broad area of 18 to 22-foot seas. That will, of course, produce like 12, 13-second period swell. But it's not till we get into Saturday that things start waking up again up here in the North Dateline region with, let's go to Sunday morning. There we go. 41-foot seas, building to 45 feet. What do we get? Yes, 45 feet in the North Dateline region. So this is pretty far to the north, but still long period sideband swell likely for Hawaiian Islands and for the U.S. West Coast, if you believe the models a week out. But, they've actually been doing a pretty good job. The fine details vary, but when you get 4 or 5 days out, that it really hasn't been horrible. The storms materialize with seas maybe 2 or 3 feet less than what was forecast, but that's not bad. I mean, if you're looking at 45-foot seas, maybe we'll get 41 or 42-foot seas out of it. Maybe. We'll see. Something to watch for. But in all, models quite encouraging, suggesting nonstop swell. The real issue is weather. So let's go take a look at the wind forecast. Here we are. This was as of 4 a.m. Sunday, the 12Z run of the model. That's Zulu time, UTC, Greenwich Meridian. Okay, add about 8 hours to that for for I'm sorry, subtract 8 hours for California, and what is that? Subtract 11 hours for Hawaii, I believe it is. All right, so this morning, 15, 20 knot winds. That's pretty much what it looked like. Pretty ragged mess along the exposed central North California coast. Hawaii under trades, pretty normal. 10, 15 knot range. We'll go into Monday. Monday, winds lighten up along the California coast. Trades start turning a little bit more northeasterly as this high starts influencing the Hawaiian Islands, but not horrible. By the end of the day, it's pretty much back to trades. California, though, by Monday evening, the beginning of south winds associated with a front building off the coast. You can see it plain as day. Trades continue for Hawaii on Tuesday, pretty brisk at 20 knots. And south winds start building for, we'll say, Monterey Bay northward at 20 knots or so. Continuing into Wednesday morning, the low just getting ready to move onshore. We'll probably start getting an offshore flow. Remember? Counterclockwise flow and low pressure. So onshore southerly flow in the south of the core of the low, but north of the core of the low, offshore flow of some degree. Trades continue on Wednesday for the Hawaiian Islands. There we go. Light offshore flow by Wednesday evening for California. But here comes yet another front. South winds taking over Northern California. Trades continue for the Hawaiian Islands on Thursday. Friday, again, south winds probably reaching down to Monterey Bay. Trades building pretty brisk for Hawaii. Get into Saturday. Wow, look at that. Strong high pressure, 1030 millibar high, driving 20, 25 knot trades over the Hawaiian Islands. South winds continue for California. Just no relief. Even into, here we are, Sunday. Still south winds fading, doing something in the afternoon. Hard to tell. What is this? Some sort of cutoff low developing just northwest of Hawaii and raking southeast winds, we'll call it. And there we are, 180 hours out. So a productive storm machine, but also Hawaii looking pretty good, being further south, more high pressure, trade winds. California, at least north of Point Conception, maybe not so much. So let's go take a look at precipitation potential. We're focusing on California now. By precipitation, yes, rain, but we're really interested in snow. All right, Sunday, yeah, maybe some little spotty patches of a little precip, but nothing much. We get into Monday, still high pressure taking over. It's the low off the coast that we're kind of interested as we get into Wednesday. Here's the core of the low. Rain for Central California into Northern California up to maybe Point Arena, something like that. Dusting of snow, maybe highest elevations for the Tahoe area. That fades out on Thursday. Now, here's massive low pressure, lots of precip. Will it actually make it into California? It keeps seeming it's like there's some sort of blocking high out here. It all gets shunted to the north, focusing on the Pacific Northwest. But then as we get into Saturday the 21st, you can see the front finally pushing onshore. Rain, probably colder temperatures. Snow targeting, there we go, the Tahoe region by late Saturday night into Sunday morning. Dumping pretty hard, it looks like, into Sunday night. Oops, and there we go. And probably a day or two of snow behind that. So maybe a white Christmas, or at least a good healthy dose of fresh snow in the mountains for California. Not bad. All right, so then we'll take a look. Here's the southwest quadrant of the U.S. We're just going to run through this. Snow precipitation, we're not seeing anything. We know we get into Wednesday. There's that little dusting for the, we'll call it the Tahoe region. Where were we? We're looking for Mount Rose, 1/10 of an inch. Okay, not much for the Tahoe regions. It's really not till we get into the weekend. Here comes the bigger of the snow events, looking pretty solid. We'll just wind this through. You can see we're into Monday, and so this is a 240-hour model. So we're out the 23rd. It kind of breaks up. So what do we got? A foot for Mount Rose. Probably get more on the over on the crest. We'll look at that in a minute. And then we'll just take this out, 240 hours. Then by Christmas, things dry out for California. So snow forecast accumulation for Squaw Valley, this is over 240 hours out. So, but for the next week, what is that, about 36 inches roughly? Snow levels, so the actual precipitation is the blue bar here. So snow levels at the bottom of Squaw or below, that's good. So it's all frozen precipitation, and winds, even not that bad. So maybe not a bad place to go to Tahoe for Christmas. We do the same thing for Kirkwood. Kirkwood's suggesting, what is that, about, I'll say 30 inches, something like that. Higher elevation, they certainly are, it will all be frozen precipitation, and winds, a little bit blustery. What is that, maybe 60 knots at the top in the main snow event, but then quickly ramping down. And then finally, Mammoth, further south, probably not going to get as much of the precip from that front, and you can see it here, 24 inches forecast, but again, with their much, much higher base, all frozen precipitation. Winds, again, up to 60 knots barely during the height of the frontal passage, but then looking pretty nice by Christmas. All right, let's take a look long-term. What's going on with the Madden-Julian oscillation, that periodic oscillation that traverses the planet the whole way around on the equator, going from west to east. When in the active state, wherever the active state is, north of there, it tends to fuel storm production, feed energy to the jet stream, producing either waves or weather. And then in the inactive state, basically doing the same thing, just kind of, it's like high pressure moving on the equator, and north of there, it basically does the same thing, steals energy from the jet stream and sort of dampens storm production some. And then, of course, ENSO, the El Nino Southern Oscillation, and we all know that when in the El Nino mode, it's like a long-running active phase of the MJO, and when, but it's isolated to the North Pacific Ocean. When it does that, the jet stream wakes up in the North Pacific, storm production off the chart, weather production too, depending on the strength of El Nino. Not all El Ninos result in the same outcome. So we'll dig into those right now. So we start off looking for the MJO, the active phase of the MJO. The best way to do that, first order of business here, is we look at winds over the Pacific Ocean. So this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. This is 5-day average winds, but it gives you a pretty good sense of what's going on. So this is the East Pacific here. This is the West Pacific here. That's New Guinea. Date line right there. Here's your equator. The arrows is what we're looking at. The colors are sea surface temperatures. Important, but not for this discussion at the moment. East winds, pretty strong over the entire East and Central Pacific and the date line, but notice they reverse direction and turn westerly over in what we call the Kelvin wave generation area. Fancy word for the far west Pacific, from about as far west as you can go, 135 east to just east of the dateline, 170 west, 5 degrees north and south of the equator. When the active phase of the MJO moves into the West Pacific and over the Kelvin wave generation area, if it's strong enough, it produces west winds or west wind anomalies. If they are strong enough and last long enough, they take warm water. You see these 30 degrees centigrade temperatures that are in this area. Takes them, starts pushing them to the east, but not at the surface. Down, they fall to depth and then travel about 150 meters under the equator the whole way across the Pacific, and after about 3 months, they erupt off of Ecuador and form a warm slick of warm water here. And if you get successive Kelvin waves by sufficiently strong and active phases of the MJO, that can be how you get El Nino. All right, so what we're really interested, though, is anomalies, differences from normal for this time of year. Yeah, those east winds look like they're blowing pretty hard, but you look at the arrows here, and what that means is, yeah, but for this time of year, that's pretty much normal. They're not blowing east any stronger or west any stronger than normal. If anything, when you get over the Central Pacific, they're weaker than normal, so you get this kind of a westerly angled arrows. And then when you get into the Kelvin wave generation area, also westerly angled, which suggests maybe the active phase of the MJO, but we already kind of know that that's not really going on. So, if anything, even though we're not in the active phase, we still have westerly anomalies. There's some disposition in the ocean, at least for the moment, sort of favoring westerly anomalies, and that's exactly what you want. So let's go look at the forecast. This is the GFS forecast. And those of you that watch this regularly know this is the whole planet on one chart. Pacific Ocean starts at about somewhere at 130 east and goes to about 80 west over here. But the Kelvin wave generation area, that's what we're interested in, from about here to about here. So you just draw a line in your mind straight up here. So this is over the past, you see, this is the past month's worth of data. And here's the Kelvin wave generation area right in here. The reds and yellows, westerly anomalies. So that would be the active phase of the MJO. And officially it died in the early part of December. And see the blue anomalies? One would say that's the inactive phase of the MJO. But we know, just by looking at the last chart, that there's still, we think, some degree of westerly anomalies kind of hanging around in here somewhere. So maybe it's not as strong as what this chart even says. And even better yet, in 24 hours, look at this. Westerly anomalies are supposed to start rebuilding, filling the Kelvin wave generation area. Now, not strong, mind you, but you know what? Any westerly anomaly is better than none, and whatever, especially when in the Kelvin wave generation area, it seems to, when you get the westerly anomalies, whether they're driven by the MJ or not, it seems to tend to feed the jet stream. And we know by looking at the jet stream charts, looking at the storm model charts, that the North Pacific is to remain active. And if anything, this would just suggest, well, that's going to continue, if not, maybe even get more active over the coming week. Good deal. We'll take it. All right, so let's go look at some other component of the MJO, outgoing long-wave radiation, fancy word for cloud cover. If you have less cloud cover than normal, you get more sunlight reflectivity off the ocean surface. That is positive anomalies here, and that would suggest high pressure, the inactive phase of the MJO. So here we are today. We think we're in the inactive phase of the MJO. Other data seems to support that, but at the same time, jet stream doesn't seem to be too bothered by it. It's doing its thing. The active phase, here, this blue, negative anomalies, more cloud cover, says the active phase is in the Indian Ocean. So over the next 5 days, inactive phase, if anything, starts moving out of the Kelvin wave generation area, and by 2 weeks from now, completely out of the Kelvin wave generation area, and the active phase of the MJO moves into the West Pacific. So if right now we're doing pretty good from a storm production standpoint, and we're in the inactive phase, where are we going to be 2 weeks from now when the active phase actually starts setting up into the West Pacific and over the Kelvin wave generation area? Well, that's per the statistic model. Now, the dynamic model, not quite as rosy. It says inactive phase, and then we basically go into a dead neutral pattern where just neither active or inactive, just a normal state. But you know what? That's okay. That's better than being in this state. So either way, the outcome looks pretty good for these two models. Let's go a little bit further out. But first off, a quick stop here, phase diagram charts. It just gives us a sense, another dimension of looking at the active phase of the MJO. All right, so what is this thing? Two different charts, two different models. The circle, assume you're looking down on the North Pole, and the MJO travels around the equator from the Indian Ocean over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. It just keeps going round and round, wherever the active phase is, and it's where the heavy dot is. And the further it is away from the circle is the strength, the relative strength. So this active phase, currently in the Indian Ocean, probably not very strong, pretty weak. And the forecast track has it moving to the West Pacific, 2 weeks out, but extremely weak. Okay, wherever the active phase is today, the inactive phase is probably 180 degrees away. So the inactive phase over the West Pacific today. All right, this per the statistic model. Dynamic model, basically saying exactly the same thing. 2 weeks from now, active phase in the West Pacific. If it's inside the circle, it's hardly discernible, so a very weak active phase. The previous two models pretty much said the same thing. Okay, let's go look at an upper level model. This is a 40-day model, so we go out a little bit beyond a month. Okay, this is precipitation, but you can loosely interpret in terms of the MJO. The yellows are areas not favorable for precipitation. The greens favorable for precipitation. So here we are. There's India, Bali, maritime continent right in there. The green, favorable for precip. There's Africa in the Indian Ocean. The yellow, not favorable for precip in the, we'll call it central to central east Pacific. Inactive phase, that's forecast to move inland over Central America, we'll say December 30th. Notice the active phase, very weak, but starts building as we get into Christmas and continues its jaunt the whole way across the Pacific into mid-January or so. And then about that time, the 14th of January, a very weak inactive phase starts working its way into the West Pacific. Now, the CFS model, different model, might predict a little bit different thing. It jumps around a little bit. December 14th, okay, here's where we are today. This is past performance. The solid black lines here are the active phase. You can say, they reach a threshold, so it looks like it's spotty, but basically this whole thing right in here is the active phase, the MJO. Dotted contour is the inactive phase. You can see the reds are westerly anomalies that died during this last inactive phase of the MJO in, when was that? We'll say late October to early November. Then we got into this long-running active phase that was the whole month of November. Here we are, December. Now, it's not showing it, but yesterday there was a dotted contour here, inactive phase of the MJO. And I think that's where we are still, but you notice here's a little patch of westerly anomalies for a week or two. Then things go neutral. Then they rebuild again as we get into later December into early January. But maybe the state of this inactive phase of the MJO is probably so weak it's not even showing on this chart. It just depicts it as neutral. We saw that on one of the other charts too. And then even a longer-term MJO model. This is a CFS model. This is a little bit different. Instead of the forecast being down here, it goes up here. Kelvin wave generation area from here to here, just going straight up the chart. Here's where we are today. You see sort of a little bit of blue here, easterly anomalies, but in a day or two, westerly anomalies supposed to show up. Continuing solid the whole way through pretty much mid-February. Then dying out, so we'll say maybe active phase here, maybe inactive phase here. Let's overlay the MJL. Let's see how close our guess is. There we go. Okay, inactive phase. Very weak, one contour, supposed to last till, we'll say, the new year. Then the active phase starts building. Now, it looks like 3 active phases, but the reality it's probably just one all big connected ball again. And very weak. These are stronger active. The November active phase that lasted a month, you can see it somewhere right in here, right? It had 3 contours. All these are one contour. So the short of it, MJO, very weak, but westerly anomalies, that's really all that matters, expected to continue in the Kelvin wave generation area. In fact, let's overlay the low-pass filter. Here we go. Okay, so the solid contour here suggests a low-pressure bias in the Kelvin wave generation area. We've been watching this for months. The interesting part here now is it's supposed to fade out in the second contour, fade out in March. Yesterday, it was supposed to fade out in late January. It's been toggling all over the place. The model's not quite sure, but we're going to move. So this is sort of like a bias favorable to El Nino. And one could almost say, well, maybe the PDO, that's that long-running, like an El Nino, like a 15 to 25-year stretch of a pattern that generally favors El Nino and doesn't favor La Nina. We think we're in the warm phase of the PDO, which is like the El Nino phase of the PDO. We think we came out of the La Nina phase of the PDO, or the high pressure phase, whatever what you want to call it, in 2014. Anyway, so this bias is set up. We don't know whether it's related to the PDO or not, but it's been steady. We're not in any kind of an El Nino, at least at the moment, but it sort of looks like we are. Also notice the dotted contour over here over the Indian Ocean. That's over in here, and that is like a high-pressure bias, like La Nina kind of thing. You don't want to see this dotted contour over here. When these two flip, that's La Nina. We're not seeing that happen. The other thing here, notice, easterly blocking pattern in the Indian Ocean. It's been here, east anomalies all winter. and looks like it's going to continue. It was supposed to fade out in January. Now it says late February. Yesterday, it actually had it going the whole way to March. So the outlook is still very uncertain. My guess is somewhere around the time of the season change. We'll say March, April timeframe. Then something will happen over here. But who knows? It looks like this is the pattern for the winter. We were very worried about it starting the early part of this year, but now, I mean, the jet stream's doing fine. The storm track is fine. It doesn't seem to be having too much of a negative impact on the Pacific Ocean. If anything, this low pressure bias thing seems to be favoring storm production. So we're okay. Yeah, we're getting rain. We're not getting particularly good surf conditions, at least in California, but we are getting swell. We'll take it any way we can get it. So with that, let's talk now a little bit about El Nino, La Nina, and the first way to do that is we look at what's going on, not at the ocean surface, but deep down in the ocean. We're looking for the presence of Kelvin waves. If we see enough Kelvin waves and they're strong enough, that could be a sign of a developing El Nino. But let's be clear. El Ninos typically peak right around Christmas. We're effectively right around Christmas now. We're not seeing any clear sign of an El Nino. We're seeing a neutral bias, slightly warm, but not enough to meet the threshold of El Nino, nowhere close. But so that's kind of the overview. Okay, so what's the chart? Here's the West Pacific. Here's the East Pacific. This is the TAO data buoy array again. The little lines going down here, these are the anchor lines on the buoys that are strung across the equator, the whole way across the Pacific, thousands of miles. Little X's are the sensors on those anchor lines. You take that data, use a little modeling software to fill in the gaps, and you get a profile of subsurface ocean temperatures. 30 degrees centigrade, 1.8 degrees Fahrenheit, multiplied times 1.8 to get Fahrenheit. But suffice to say, warm water in the West Pacific, pretty stable. The leading edge of it at 175 east. That's where it's been for a week. The 29-degree isotherm at 172. Maybe it's moved a degree off to the east. The 28-degree isotherm at 162. That's steady, if not slightly moving to the east. The 24-degree isotherm. So this was pushing into Ecuador. Now it's starting to back off. I mean, you can see a little piece of it here, but basically it's back at 115 west. And what happens is when you get Kelvin waves, this warm water, get westerly winds or westerly anomalies blowing here, they take this warm water and start pushing it at depth the whole way across the Pacific. Eventually it erupts off here, and then you see all these isotherms start pushing off to the east, suggesting warm water moving to the east. All right, but it is the differences from normal for this time of year. They call it anomalies. That's really what we're interested in. You can see here's, again, just off of Ecuador, warm water, 2 degrees centigrade, moving in. This is a Kelvin wave number 5, erupting weekly into Ecuador, and Kelvin wave number 6 developing from the westerly wind burst, the active phase of the MJO that happened back in November. Now remember, it'll take another 2.5 months for this warm water, 3 degrees centigrade. So what's that? Times 2, 6, like 5.5 degrees, 4.5 to 5.5 degrees above normal to make it the whole way across the Pacific and start erupting off of Ecuador. So what's that? We're in December, January, February, end of February, early March, something like that off here. Okay, but even in between, there's weak, warm anomalies or neutral. So no signs of like big cool pockets or anything here. Now, interesting, this summer we had cool surface water, cool anomalies over here for like 3 months, and we literally were sitting here saying, this isn't good. It looks like La Nina developing. It looks like, this isn't good for California precipitation, because when you get cold water south of California on the equator, that tends to it shuts down the jet stream, it shuts down the storm machine, and things dry up. But that is all evaporated magically. We've been in a pretty good pattern now for a month or so. We'll take a look here at another chart in a second. And rightfully so, the jet stream and weather has been happening in California. We've got, a good snowpack, seasonally normal, if not above normal. And we've got good rainfall. So, hey, maybe we're going to work out a little bit better, at least in terms of precip this year, than what we thought. Here's a little bit higher res model of the same data. It's showing the same thing. Kelvin wave number 5 working its way into Ecuador. This is the West Pacific here. Here's a little cool patch, but not horrible. Here's the next Kelvin wave, and literally just draining off the maritime continent into the West Pacific, still building, which is good. I mean, this looks like a pretty healthy Kelvin wave setting up here, so not a bad pattern at all. Sea level anomalies, just another way to infer where warm water is warmer than normal water in the Pacific Ocean. So there's South America, Central America, Mexico, New Guinea. There's your equator. There's your date line. All right, so this is JSON 3 satellite data. Strip out all the wave heights, strip out the tides, strip out the wind waves, and you just see, is the ocean higher or lower than normal, for this time of year? And what we see is a giant area of 5-centimeter anomalies. That's not very much, but what that means is warm water at depth expands and it creates a bulge on the ocean's surface. That's what this is, suggesting warm water at depth here. Kelvin wave number 6 doing its thing. And even more interesting, this isn't much. It's 0, maybe 1 or 2 centimeters above normal, but we had negative anomalies along here for months, and almost like a triangle forming out here in the summer, and that's when we were saying, hey, it looks like La Nina is developing. That's all gone now. We know there's a Kelvin wave erupting here, and we see little signs of that, but there's clearly no signs of La Nina or any of that, what was happening this summer. Whatever that was, it's just kind of vanished, and that's good news. Upper ocean heat anomalies here. So this is for the area from the date line to 100 west, basically on the equator. It's 5 degrees north and south. You just get a sense of the volume of warm water that's Kelvin waves in flight. And you can see in January, February, March, we were in a pretty good pattern. And then we got into this summer thing. It started in the June time frame. And the amount of warm water in the central Pacific at depth really dropped off. And then here is the current Kelvin wave that's erupting. It's about done its thing, but we know there's another Kelvin wave coming. There'll probably be another bump out here somewhere, probably a little bit. But all it says is appears to be a bit more warm water than there was this summer, all again speaking to this pattern of it was cold, the jet stream wasn't favorable, and all that, and now there's more warm water in flight. The Kelvin wave cycle is waking up again, and the jet stream appears to be responding in kind. Upper ocean heat anomalies. This is the East Pacific here, West Pacific here, time. And these are temperatures. You can just literally see this was Kelvin wave number 3 here. Kelvin wave number 4, January a year ago, made its way across the Pacific. And then here is that big ball of cool water that happened back in June, July, August that we go, and we had 2 mini Kelvin waves, and they stalled. They made it to the Central Pacific and just died. It was like, is La Nina trying to organize? And the models miraculously said, no, it's not going to die. We're not going into La Nina. And sure enough, they were right. Out of the middle of nowhere, we got this other Kelvin wave that developed back in the September time frame. It has made it the whole way across the Pacific. This is the one that is erupting off of Ecuador at this very moment. And then here is Kelvin wave number 6 right here, developing under the date line as we speak. You saw it on the previous charts. And we expect it, too, to make its way the whole way across the Pacific. All right, so then, sea surface, not subsurface, surface temperatures, anomalies, differences from normal for this time of year. We know here's Ecuador, Central America. We know the Kelvin wave is under the equator, somewhere around here, erupting to the surface, and you can see it, actual warm temperatures building along Peru. Nothing huge, nothing marked, but the interesting part about this is here's this cool pool here off of Peru and Chile was quite a bit larger this winter. Now it's sort of, and it was right up to the equator. Now all of a sudden it's getting pushed south. I mean, we have very gentle warm anomalies to almost 10 degrees south. And it is this warm pocket right in here that we think is helping to support the jet stream, helping to drive energy into California, feeding the moisture flow that's currently ongoing, which is good news. We want this to continue, But we also know that the Kelvin wave that's hitting right now is at some point going to fade out. We're going to lose some warming here. But hopefully there's enough momentum so the atmosphere doesn't like instantly turn on and off based on presence of warm water. It sort of takes weeks or even months to reconfigure itself, and in the heart of winter, with gentle warming in this area, and the jet stream basically trained pretty well on California, we suspect this pattern's going to hold, and maybe as soon as that next Kelvin wave makes it over here in late February, March, that will continue to feed the pattern, and we'll even have a nice wet spring pattern. Now, that's probably way too much to hope for, but that's kind of the thinking at the moment. Here's the sea surface temperature trend for the past 7 days. 7 days is not really a trend in any stretch of the MJO or El Nino sense, but still, we can see a marked area of warming all off of Peru and Chile. This is, and this area was and has been colder than normal. We see warming going on here. This is why we're kind of going, and there's California. It's south of California on the equator. If you get, and you got to get not just to California, but you got to push pretty well inland because the jet has to move inland, and that would, if it just makes it here and then splits, that's no good. But when you see warming out in here, that generally helps encourage the jet to move into the western U.S. coast, into Colorado and that area. And we see this, if this continues, that's a good sign. Now, we notice we do have a couple little pockets of cooling that showed up on the equator. But again, this is just a 7-day trend. Let's go look at the actual sort of broader pattern. All right, so here is sea surface temperature anomalies for this time of year. You see, here's that warming building along Peru and Chile. And then right in here, this was all somewhat cold in the summer. It's warming up. And you see, this is, we're really reaching here, but warming even down in here. This is not a strong marked pattern. El Nino would be a big old red blob going like this. We don't see anything like that. We're just trying to tease out, is this warming here? If it persists long enough, will that encourage the jet stream to continue pushing into the California region, driving moisture into the coast? And at that, it also helps encourage the jet stream just be stronger in the Gulf. Wherever the bulkier warm water clearly is here over the dateline into the Central Pacific. Great for Hawaii, the dateline region doing well. But a little bit more of this coming this way is good in terms of precipitation. Of course, that's also not great for conditions in northern and central California. It's been a pretty jumbled mess, to say the least. For as long as we've had swell, there's only been little tiny windows of an hour or two here and there that any of it's really rideable. But anyway, that's sort of the thinking at the moment. Here's a sea surface temperature anomaly trend. What's actually been going on in the Nino 1.2 region? That's that area right there by Ecuador, Peru, Chile kind of thing. Temperatures today, minus 79 thousandths of a degree below normal, basically dead normal. And you can see the trend. Here was back in summer, that cool pool. We kind of pulled out of it, looking pretty good in early December. We've dipped off. Question is, are we going to rise back up a little bit here and stay there? Too early to know. The official El Nino monitoring region, Nino 3.4, this is out like south of California, 120 west out to the dateline, 170 west, 5 degrees north and south of the equator. All right, for El Nino, you got to be half a degree above normal for 5 consecutive months. Well, here's the half a degree mark. We're not there. We barely touched it for 1 day and 2 days in November, and then we fell off again. Today, we're 133 thousandths of a degree above normal, 0.133. So nowhere near El Nino or anything like that. But we are above normal, which is good. If we were a bit more above normal, that would be better. But at least it's way better than being down in La Nina territory where you're below normal. What is the atmosphere doing? Does the atmosphere, we talk about the jet stream sensing water temperatures and things like that. And the atmosphere, so there's an index, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When there's lower pressure over Tahiti, meaning in the Pacific Ocean, the index goes negative. If it's negative for a day or two, that doesn't mean a whole lot. Right now, we're at minus 14.90. But you can see we've kind of been toggling all over the place. Basically, this is like If this goes for like 15 or 20 days, then at negative, somewhere in the negative range, then you can say that's the active phase of the MJO, right? Okay. The 30-day average is a good way of looking at it. Right now, we're at minus 5.38, but you go back in time. So look where we were back in, here's November, and it's sort of a lagging indicator. This was the active phase of the MJO. We were down here at minus 9 or whatever, right? Now we're fading off to minus 5.38. Okay, so it looks like the active phase is gone. We're moving towards the MJO neutral. The 90-day average is like your El Nino indicator. It needs to be down about minus 15. We're at minus 6.3 today. Where have we been? Well, minus 9. So we're ENSO neutral, biased weakly towards El Nino, but not enough to declare it El Nino. So in all, just like the sea surface temperatures, just like the Kelvin wane thing, everything, we're clearly not anywhere near La Nina, but we're not towards El Nino either. We're biased just the weakest bit towards El Nino, which is a better bias than anything. And hey, we're getting rain and, we're getting storms, so not horrible, but, not great. We'll call it average. One could debate whether the swell season is even average. It certainly took a long time to get going, but now that we are going, it's feeling a lot more normal than it was. And then finally, the sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region. That's the official El Nino monitoring region. All right, so this just updated actuals, showed temperatures into November at about 0.25 degrees, a quarter of a degree above normal. Again, you got to be half a degree for 5 months to declare El Nino. So this is this, and the sea surface temperatures biased warm, but not that warm. Forecast for the rest of winter, basically holding somewhere around there, continuing the whole way through a good portion of the summer. And then as we get into the fall of next year, or of 2020, maybe going weekly negative. The model, sometimes it says more negative than others. Sometimes it says staying positive. In all, you're looking here, we're not in El Nino, but it seems like we kind of are, but we're really not. It sort of smells a little bit like the warm phase of the PDO, nudging things a bit warmer than normal. And that's a good place to be. Again, that could mean 15 years of better than average. This is the long-term average in terms of storm production and water production for California. So too early to know. We've been in it, maybe 5 years now. Probably won't be another year or two. But I think we're probably in the warm phase of the PDO at this point. All right. So the quick synopsis. Well, Jetstream's doing quite well. There's one storm already pushed over the dateline. Swell is in the water, pushing towards Hawaii, the U.S. West Coast. Another one is developing over in the far West Pacific. It's supposed to do the same thing, produce yet another swell pushing towards Hawaii, U.S. West Coast. And yet a stronger one is forecast for the North Dateline region a week out. And again, the same expectation, reasonably large swell developing from that. Weather, major concerns for California. The good news is, hey, there will be weather. There will be rain. There will be snow. Build up the snowpack. If the surf isn't good, you can go to the mountains, get your board, go boarding, go skiing, whatever, go backcountry, you name it. Be safe, though. But the short news is the Pacific is alive. Things are looking pretty healthy, and it's a vastly better picture than we would have thought back this summer when things looked rather bleak. Long term, no El Nino coming, nothing like that, but we think at this point the rest of the winter could continue somewhat similar to where we are right now. And that is good news. All right, so if you enjoyed the video, give us a thumbs up, hit the like button down there below. If you haven't subscribed, you're welcome to do that. The subscribe button is below. Put in your email address. It'll send you an email when we update these videos, which is about every Sunday, give or take, depending on snow and surf and whatever else is going on. And also, let's see, you can always visit stormsurf.com. All the data, or most of the data you saw here, is on that site, and you can monitor along and then get the update later on the weekend and sync up and see if your forecast is the same as what we're thinking. And if you don't understand something or you don't agree with our forecast, leave us a comment and we can talk about it. And maybe I'll learn something from you and we get to all share information together. All right, so that's it for this week. We'll do it again. We're thinking next week, but it sort of depends. We're getting really close to the holidays, but if not, for sure the week after that. All right, thanks again, and we'll see you hopefully next week.